Right here we have the ladder logic program for our shaft that we're rising and lowering. We have a stop red button, push button that is representing the stop red button right here, this one. And it's in series with a green push button that's also on the right there. And it's in series with other sensors, with a high sensor and with the down motor, signifying that when all these are true, the up motor will start. So if I press the green button, it'll latch on real quick. Now really quick for the down, so they'll stay on. You can see it does a closed circuit right here, so it runs through completely, causing the motor to go down. And when it's fully down, the light will stay lit. And should make it go bigger, please. When it's rising, it'll blink green, and when it reaches the top, it'll stay green. Now, that blinking on and off is done right here in the program. As you can see in this part, we have these blinkers going on and on. That's part of the program itself, enabling a light to turn on and off at that rate. If we want a faster rate, we decrease this bit number. Could you do another one, please? Making it go down makes this run true, making that light blink, let it go down. Finally, when that down motor is complete, it turns off, causing this one to turn on, completely passing the blinker and making the light stay true constantly. Going lower in the program, we have the yellow light situation. It's when we want to make it blink, when we don't want to make it blink, when the light should turn completely off. As you can see right now, none of these are true, so the light is off right there. But if we were to make it go back up again, we'll see if these three components will make that light true. And this is the program we use to wire this setup.
Could you explain each one of these components and how they're all interconnected?
Sure. Yeah. What we have is an actual simulation of pretty much an industrial door, opening and closing. Also a flashing warning light system in case there's a lot of noise. You need to actually see what's going on. Right here we do have the actual motor and shaft of our system. This is what would open and close the door. We also have sensors on the side of the system that we wired in so that we know when the door is actually all the way to the top. It shuts itself off. When it goes all the way to the bottom, it shuts itself off. We also have this wired into a power source. This system here is our power supply. We're running off of 24 volts right here. And we also have our warning light system that also is relayed into the whole system through a PLC, which is our programmable logic controller, which he just explained. We program a program and it tells the actual computer inside of here what to do when we do something. We have a couple of relays that everything's run through here, and then our push button system for if we want to manually open, close the door, and like I said, it will shut off by itself due to our sensors. So we can actually close the door, and our warning light's telling us. So if you cannot hear, you can actually see the warning light going, and it's on. You can actually stop it. You'll see that the warning light's going, so you know it's stopped. Get yourself out of the area if you need to, and then you'll go fully closed. It shuts itself off as soon as it hits the sensor. That's pretty much our whole door simulation system run through a PLC, controlled by a PLC. Now if we wanted it to do different functions, all we'd have to do is put in a different program in the system, and we wouldn't have to change any of our wiring here because we can change everything that this does with our PLC programming in the ladder logic.